Hello, welcome back.
Thank you.
Guess I'm going to screen share again.
All right. I have no idea why it stopped broadcasting, if I accidentally hit it or what happened.
Hopefully Robert can make it back.
I posted it in Piazza. I put a link in the old Hangout, and I gave it to you directly. So.
I guess we probably should have told him what we're doing before we hung up on him.
Well, he could hear.
All right. Welcome back. Sorry about the technical issues, Robert.
I'll bring up the chat. So, anyway, any questions about what we're doing, where we're going, what's the goal of this class? I kind of think of this class kind of like 241 reteaches you Calc 3. This class kind of reteaches you differential equations.
I haven't taken 241 yet. How is that?
It's probably one of the hardest classes, and it is the hardest class in lower division.
Oh, I've read it's the hardest class in the entire program.
Yeah, it could be arguably the hardest class in the entire program. Yeah.
Yeah.
Okay.
I don't know which one's harder though, 241 or the engineering electromagnetics follow-on class. Let me look up the Tripoli number.
The 341.
341. Yep.
I thought EMAG 2 was easier, but that was because different professor, Dr. Herbal, or I can't say his name right.
I heard that Dr. Formicone is basically just reading equations the whole time to us.
Yeah.
Okay.
Yeah. I've always wondered why people say why people get worried about their professors, because all the lectures where most of the learning comes from is like from the pre-recorded sessions from years ago from some other professor.
Yeah.
Well, the lectures are the professor's the one who decides the test, so I think that's a lot to do with it.
True. But yeah, I didn't have one of those classes. Yeah, they say you're either really good at Signals and Systems 1 and not as good at EMAG, or you're really good at EMAG and not as good at Signals and Systems 1. That's what I've heard.
Yeah.
Okay.
So Robert, what kind of notes he should put on his cheat sheet, and don't put anything that's on these key concept sheets. So all 4 of these key concept sheets, if you can see my screen right now, these have been provided every week throughout the course. These are already going to be provided on.
I don't think so.
What?
I don't think the key concepts are provided. It's just the tables.
I'm
not sharing my screen. I'll take a look and make sure.
Okay.
Well, I'm pretty sure it's just the tables. Midterm. Let's practice exam.
Let me go ahead and pull out my cheat sheet. I keep all my cheat sheets from every class every semester, so I'm going to pull mine out and I'll just go through it real quick. The tables he's referring to is like your Fourier series properties tables. So like if you're looking at my screen, this table right here, table 4.1, and this table 4.2 are the tables that he's talking about. These tables will be for sure on the midterm.
So those are on the final. The only looks like right now is table 5.3, table 3.1, properties of continuous time Fourier series, and table 3.2 Fourier series. That's all I see. You can give it on the exam.
Okay, I got my cheat sheet here, so I'll just go over what I put on mine real quick. Now this is from like over a year ago, so the exams have changed. They won't change by a lot, but and then also not everything I put on here was necessary since we were provided with some of the stuff on the exam. But I definitely got Euler's identity, a couple different versions of it too, just to make it easier. So I wrote it down for the cosine of theta and the sine of theta, and then the traditional definition as well, where it's e to the j omega equals cosine theta plus j sine theta. That's the default one. I wrote down the two geometric series that we worked with in this class. The one where the sum is over a limited range, and the other one with the sum that's over k equals 0 to infinity. So both those geometric series are important. I basically wrote down definitions for every single concept that we went through. So like the definition of the energy in continuous time and discrete time, and for power and CT and DT. I definitely wrote down shifting properties and sampling properties because those are some of the most useful when it comes to solving problems. Because a lot of problems will be given that has some kind of direct delta in it, and that direct delta can be used to greatly simplify your integrands to make them almost trivial. So you definitely want those. I got definitions for causality, time invariance, linear, invertible, all that stuff, memory lists. Got the definitions for convolution, both in, oh, hi Lee. We're just going through some stuff. Right now we're talking about notes that are beneficial for the cheat sheet, just to get you caught up. But yeah, so the notes that I wrote on my cheat sheet for convolution, I wrote both the generic definition and the definition with the integral. And then I know a lot of other students that I took the class with wrote down a couple examples of convolution. You know, one with like a couple unit step functions and one with a couple direct deltas, just to see how they behave inside the integrand. So that might be beneficial.
Yeah, anything you had problems with, and any homework problem I had an issue with, like I just didn't understand, I would put on my cheat sheet.
Yeah, I definitely wrote down convolution properties too. Like convolution is commutative, distributive, and associative. So those are all the same definitions from generic algebra 1 class. But I wrote them down anyways, just because sometimes on exams they'll show you a block diagram, a block flow diagram. And if you have, you know, 2 blocks in parallel versus 2 blocks in series, how does the convolution behave in that circumstance? So I drew those out. And you know, drawing those out translates directly into those definitions of commutative, distributive, and associative. So you definitely want to know how those behave or work out. Let's see. You flip it over to the back. I didn't write a whole lot on the back. So on the back side, I wrote, it looks like I wrote just a quick definition of, or a couple examples, I guess, of your complex numbers. So the 2 forms, rectangular and polar, I wrote them both down. You really don't work with polar complex numbers in this class at all. So I don't really know why I wrote it down, but I wrote it down anyways, just because, actually I know why I wrote it down. So we're used to seeing complex numbers in rectangular form of the form a plus jb. But in this class, a lot of the homework problems are complex exponentials, or after you've used Euler's identity and converted a sine or a cosine into some complex exponential, that complex exponential is going to have a magnitude, which is the coefficient in front of the e, and then a phase, which is the value that's after the j in the exponent. And that, so every time you see a complex exponential, that is the polar form of a complex number. And put another way, that is a phasor. If anybody's taken Circuits 1 yet and knows what a phasor is, that's a phasor.
Also, useful note when you're entering complex, if you don't have the rectangular form, you have the polar form of a number and you need to enter it in the math lab, using the exponential form is the way to do that.
Yeah.
It's the only way I found to enter it in the math lab. I've had to find that out in other classes. We'll start using math lab heavier in future classes for sure.
Yeah, I used my TI-83 Plus graphing calculator almost exclusively in this course for the exams. So you can also convert between rectangular and polar form in your graphing calculator if you just input it. And you can change the mode to automatically display results in one form or another as well. And then the graphing calculator also gives, just like MATLAB, it gives you the ability to just put in a command for magnitude, absolute value of, which is the same thing, and then phase, so you can return just those results if you need them for some reason. And then somebody in Piazza asked yesterday about what trig identities to write down. And honestly, from memory, I don't really remember using a whole lot of trig identities, if any at all. But I wrote down a whole bunch on my cheat sheet anyways. So where I got my trig identities from is this website called Polls Notes. Pulling it up on my other tab, so let me just display it so you guys can see it. So I typed in Polls Notes trig in Google, and the first link, Algebra Trig Reviews, Polls Online Math Notes from Lamar University. In fact, this guy, Paul, whoever Paul is, he makes cheat sheets for all math courses, including calculus, multivariable calculus, differentials, algebra 1, 2, 3, 4, 5, all the algebra classes, your trig classes, pre-calc classes, everything. Pretty awesome, actually. But I went in here for trig, and I just I printed all these out, so I keep them in my desk at all times. Hold on, I need the actual link, or the PDF. Let's just click this thing, see what happens. Trig formulas. Okay, this isn't helping me. Oh, here we are. Trig cheat sheets. So I don't want to download it, I just want to view it. Well, I guess I have to download it. View it. So this thing right here, I just pulled this up, and then I scrolled down to these formulas and identities, and I just wrote down a whole bunch of them on my cheat sheet. Now, from memory, and hopefully James can correct me if I'm wrong, I don't really think we use any of these.
No, maybe the phase shift, but
yeah,
I don't really think you have to do that on it. I know we use that in the homework, but
yeah, but I wrote them down anyways on my cheat sheet because I actually had room for it on the back side. So it's up to you if you want to include it or not, but you can never be too prepared.
yeah, I put the tables on the back of mine just because I knew I wouldn't be able to like print them out, and I don't like using hard or soft copies because you only have one screen, so you got to flip back and forth between.
Yeah, speaking of which, I hate ARP now. Like, I have dual monitors, and
oh yeah,
I feel like I should be able to get dual monitors. Oh, definitely write down some examples of time shift and time reversal and scaling. So in the very beginning of the course, in the first week, we learned how to draw signals and then time reverse them or shift them or whatever else. Draw some good examples of those on your cheat sheet as well. Definitely write down the formulas for finding the period of a signal, where omega naught equals 2 pi m over n for a discrete time, and 2 pi over t, the period for continuous time. Definitely write those down. Robert asks, can you explain that more? Are we entering answers in this exam, or are we just? Oh, you're doing the stuff on paper and then scanning it.
Yeah.
So you're actually gonna have to solve the problem and not just come up with a solution.
This may be the first time you've had to do that, but it will become commonplace when you get to the level classes.
In fact, I can't even remember the last course that did a multi or what are they called? Multiple choice questions. So what I mean by entering in polar form, so with complex exponential or with complex numbers, let me go ahead and pull up a cool little.
Yeah, you have A plus BI.
Yeah.
And then you can find the magnitude by squaring A and squaring B and adding them together, then the square root. And then you can find the angle by the way you convert any number from rectangular to polar, really.
Yeah. So, Robert, have you seen this sheet before in the class? Review of complex numbers? Robert doesn't have a mic, so I'm just waiting for his text response. Yes, apologize for the vague question. I mean, you were talking about. Oh, yeah. So earlier on my cheat sheet, if that's what you're talking about, on the back side I wrote. I just wrote, for example. Well, let me just stop screen sharing. I'll just show you the camera, I guess. How do I stop screen share?
You just did.
Oh, I did?
Yep.
Oh, yep. Okay. So hopefully my camera can pick this up. It's low resolution. It's kind of crappy. Can you guys read that? That is the way you want to put it in MATLAB. So in polar form, both in MATLAB and a graphing calculator, such as the TI-83 Plus, if you have a complex exponential, let me go to a homework problem example. If you have a complex exponential that looks like a good pretty one. So like this, and then, so this what I have, oh, I got a screen share again, I'm sorry. All right, so this is one of the homework problems from the first week, and this is just a complex exponential right here. And we see these all the time in the class. After you've used Euler's identity on a cosine or a sine, you convert it into this form. And all you've done is you convert a sinusoid into a complex exponential. A complex exponential can be written in two forms. In polar form, which is what you see here highlighted, with the magnitude in front and the phase in the parenthesis of the exponent, or in rectangular form. And we really haven't seen rectangular form in this class at all, but you've certainly seen rectangular form in other classes, in like your physics or math classes, just other classes in general. And if you wanted to convert it to rectangular, or if you got a result that was in rectangular and you wanted it in polar form, you just input it into your calculator or MATLAB, and then just, I don't know what the command is for MATLAB off the top of my head, but there's cheat sheets out there, and James could probably tell you. But in my
EXP parentheses.
Yeah. But in my graphing calculator, I would just type in, let's say I have 2 plus 3i, and I wanted to put that into polar form. I would then hit the math key, and then scroll over to the CPX menu, which is complex, and then scroll down to the 7, which is polar, conversion to polar, and then hit enter, and it'll come out with the exact same number, but in polar form. So 2 plus 3i becomes 3.6 e to the 56.3 degrees. Now, if you're doing this in a graphing calculator, please be aware of what mode your calculator is in, because it might spit out the number in radians for the phase, or in degrees, and you don't want to confuse the two. Hopefully I'm not confusing you too much, Robert, because I'm not going to lie, I don't think I really did this very much during the exam either. Because
Yeah,
you're
this
not
is
going to see rectangular form.
more generalized how to handle complex numbers and what you're going to
Yeah. And I would.
Where is that complex numbers review sheet? I can't find that in the course.
Oh, it should be week 1.
Let me take a look. So I'm gonna swing this over to this monitor and we'll go through it together. Now you're looking at the instructor view though, so let me go ahead and hit student view. And then we'll pop down to modules. It should be in week 3.
Oh, was it week 3?
Probably in other resources. And there it is right there.
There
So
it is.
module
Okay.
3, other resources, complex number PDF. And then that other document underneath the ESF at 12 CN stud PDF. All that jazz right there. I think that's another cool worksheet. So let's just look at what that PDF is real quick. Yeah, this is another, it looks like a scan from a textbook, but it's another kind of sheet that goes over complex numbers.
Okay.
I don't like that. So this one's 11 pages long. It's a little long, but you could probably get away with this this one, the review of complex numbers, that's only 4 pages long. It gives all the quick and easy properties, I guess. So to maybe further answer Robert's question about why we would go from rectangular to polar or polar to rectangular, so this is why right here. So in the rectangular form, it's easier to add and subtract complex numbers. But if you have to multiply and divide complex numbers, it's definitely easier to do it in the polar form. So that's why we have these 2 forms. Plus, it depends on what you're doing. But when you graph them in rectangular versus polar form, different forms might be useful for different things. For example, in future classes, if you go to EMAG and then into like microwave circuits for track, I guess, when you get into a Smith chart, that is the complex plane in polar form, and you definitely want to understand it.
Smith charts.
That's a future class though, and you might not take it, so
Yeah.
take it with a grain of salt, I guess.
Well, if you go to the power route too, I'm taking 360 now and I'm converting back and forth all the time.
Yeah.
It shows up a lot of places.
So this is a Smith chart. And this has nothing to do with this course, so hopefully I'm not just wasting time, but you can kind of see that this is a polar form because everything's round, and it's a complex plane where this is the real axis, and then these are the imaginary axis, all these little curved lines. So to be able to understand this Smith chart in future courses, you're definitely going to need to understand complex numbers in general.
Yeah, but if on your test, if you're converting to rectangular, you've gone wrong somewhere.
Yeah.
I think that's a safe assumption.
Yeah, I would agree with that.
Any other questions? Lee, do you have a question? Anybody? Mueller?
Well, if you have questions, that's what we're here for. So don't be afraid to ask them. You know, we're non-judgmental.
Yeah.
Since you joined late, Lee, at the beginning of this thing, I wanted to give a plug for our pre-recorded midterm review video that's posted in Piazza. Me and James recorded it like 2 or 3 semesters ago, and it's basically us going through every single midterm review in depth with techniques and why we did certain techniques and what knowledge makes it easier and all that kind of stuff. So I highly recommend watching that. It's a little long though; it's about 2 hours long, but I definitely recommend watching it.
For the exam, I think it's pretty much one question for like every topic we've done. We've done system properties, so you have a system property question. We've done convolution, direct time, or discrete time, so you have that convolution, continuous time. So it's, I think it's just, I don't know how many questions total.
I think it's an even split.
Yeah. Oh, if someone's got YouTube, I think they're muted. Yeah. I haven't given up YouTube, so I don't know how to. Maybe I'm echoing? No, it's not. Yeah, everything. Yeah, nothing on chapter 4 though. If you've gone that far yet.
Are you looking at the midterm right now?
No, I'm not.
Oh.
That's the way it's been in the past, so I don't think she's changed it.
So I'm looking at it right now, and it looks
Pretty similar.
there's multiple parts to each question, and there's 1, 2, 3, 4, 5, 6, 7. There's 7 questions with multiple parts each, and it looks like they go pretty evenly between chapters.
If they can't read it, they can't grade it, but there's a lot of leeway for penmanship. I just said try to be as neat as possible. Also understand that you have a time limit. I don't remember time being an issue on this test, though. I know I taken a lot of tests that time has been.
Yeah.
This one is that bad.
Yeah, I think this exam is what, 2 hours long or something?
Yeah, something.
Yeah, you get plenty of time. It's one of the only courses where I didn't feel rushed in the last 2 years that I've taken at ASU.
I don't. Yeah, I think so. I have one. I don't use it a lot because I don't like the Inspire. It's hard for me to use. I've been using my K83 for longer. Yeah. So it's great technology, but if you don't have a good way to, yeah, that's fair. Backup's always a good plan. I always keep a set of batteries every time I take a test in case my batteries die on my mouse or keyboard or.
I used to do that too, but I stopped doing it after a while. But I probably should do it again. I'm looking through the course shell to see if there's an announcement that specifically lists calculators.
I didn't find one when I looked for one.
Yeah. Most after you're out of the math classes, the only class I've seen that has banned the Inspire is my statistics IEEE 380. They ban it, but other than that, they let you use the 89. So I'm like, I don't understand that, but okay.
Yeah, I think the calculators that are banned are the ones that do symbolic calculation, where you can just input an equation and it'll with no numbers and just variables, and it'll solve it for you.
Yeah.
Which is just funny because can't MATLAB do symbolic?
Yeah, exactly. MATLAB can. Yeah.
Yeah. The exam says any calculator. I believe it specifically says any calculator and any computer-based calculator.
Yeah.
So it's allowed.
I know this is off topic, but 241 is that the same where it doesn't? If you guys remember, it doesn't matter what calculator.
Number calculator restriction in that class.
Yeah, I'll pull up the course real quick and look over the announcements and the syllabus from that class, since Blackboard saves it all.
Oh, for sure.
You said 341 or 241?
241.
241. Okay.
If this is your first time using Canvas, there's a different version of RP now you have to download.
Oh yeah.
Forgot to mention that.
Oh, okay.
You gotta go through the RP now in the Canvas shell. Otherwise, it won't work. You won't find your class. When we first swapped over to Canvas, we had a lot of students not able to access their midterm. We found that out.
So on the 241 general exam information, it says verbatim, the exam is closed book, notes, no laptop, no tablet, no smartphone, no smartwatch. You're allowed one cheat sheet to write equations hard to memorize during the exam. A computer, tablet, phone, or watch is not allowed. To receive full credit, show your work and double write, and in doubt, write more. You can use a scientific, non-programmable calculator, is what they wrote. But I think when I read that, I posted in Piazza and asked the professor, and he said, "Oh yeah, TI 89 is fine." But let me hop in the Piazza for that class if Piazza saved it, and I'll try to find that when I post that question and see what the professor said. So I took the class with Formicon. So you might have a different professor who might have a different policy, but
I'll have Formicon. Yeah.
Okay.
I appreciate it. Thank you.
No problem. I'm actually kind of glad that Piazza and Blackboard saves all this stuff. Now I did notice that Blackboard only saves classes from the last 4 years, but after that, or I'm sorry, last 3 years, but after that it deletes all that stuff.
Okay.
And on this class, it says the midterm is closed book, closed notes. You may use 8.5 by 11 cheat sheet, 20 pages of blank scratch paper, which is a lot. Handheld or computer built-in calculator during the exam. I don't know if that is MATLAB or not. Sounds like it.
Here it is.
I'm not going to officially say, hey, yeah, you can use MATLAB.
So here's where I asked Professor Formicon if I could use a graphing calculator in that class. I'll pop it over so you can see it. And for anybody else that's listening, or maybe somebody that joins after, this is talking about a different class and not talking about EEE 203. Just want to put that disclaimer out there. But here's why I asked if I could use a TI-83, and this is where the Professor Gabriel Formicon says it is fine. So I used my TI-83 on that exam. So he wrote the reason why it was fine is because he's grading handwritten exams. It's not multiple choice. So he's going to be able to see if you understand doing an integral or a vector transformation or line integral or any of that stuff, and not just having a calculator do it for you.
Okay.
He wrote here, instructors already know that a high-end calculator with a calculus app can do it, but we need to assign a grade to students, not to calculators. Therefore, to earn a full grade, students must show the intermediate steps, and most importantly, show that they understand and know how to do the certain calculations that a programmable calculator would also be able to do. So it's fine if you have a calculator that can give you answers, but you got to show how you got those answers.
Okay.
Yep. And when you take the class, I would definitely ask this question again and not just assume that he's keeping the same policy from
Totally.
10 months ago. So this was almost a year ago that I took this class.
Okay.
Yes, RP now is. And like I've said, if you get, I don't know if you've read the test taking tips I've put out there, but the RP now seems to be more sensitive. So if you get an email that says you've been flagged, don't freak out. But try not to talk to yourself and try not to have stuff on in the background. What is the most missed problem on the test? I don't know. I don't grade them.
Yeah, we're not allowed to grade exams, and every exam every semester is different anyway. So it wouldn't matter if we even knew it from last semester because it'd be different this semester.
If I had to guess, it'd probably be the
4-year series,
maybe, or 4-year series, because that seems to trip a lot of people up.
Yeah.
But if you, I mean, there's a lot of partial credit given. So I know when I took my test for this class, they had 25 or 30 short answers that were multiple choice, and then we had like 5 of the write them out. And I got like 50% on the multiple choice part, but I still aced the exam because I did well on the write it out part. So I prefer the write it out part.
Yeah, there was a lot of extra credit when I took the exam as well.
Yeah. Yeah, there's 170 points possible out of it, and it's only out of 150. So.
Yeah.
There's about 10% extra credit in the whole course, I believe. It's all added up.
Yeah.
Between the extra credit on the quizzes and extra credit on the exams, and then there'll be a extra credit lab. So you're out of questions?
So let's see, we definitely want to know how to transform from complex exponentials to cosine and sine, right?
Oh, for sure.
Yeah, okay, cool.
That's fundamental to the class. I mean,
yeah,
one of those things.
That specifically is really good for when you do a 4-year series and you're trying to figure out the AK coefficients.
Yeah.
If you're given a sinusoid, when you convert it to using Euler's identity to complex exponentials, the coefficients of those complex exponentials become your AKs.
Yes.
In a sense.
I guess one of those things that I wasn't always completely sure about is, so like you have the AK coefficients, but sometimes you have like -5, -2, A0. How is it that we always know that it's like, that we know that they're those coefficients?
So
that's from the omega naught. Your fundamental.
Okay, that makes sense.
Also, so 4-year series is working with periodic signals. Later in the course, in week 5 or 4, whatever, when we get to Fourier transforms, where we start work with non-periodic signals, aperiodic signals. But for periodic signals, you know that they're periodic. So when we pick our AK values, you can pick any set of AK values for any given period, as long as the period makes sense for that signal. For example, we in this course or on the homework problems, we see a lot of A1s, A-1s, A0s, A2s. But if you shifted those all by one period, you could work with A7, A8, A9. They'll be the same values and they'll be the same like pattern or shape, but they'll just be shifted over by one period. Does that make sense?
Yeah. Okay.
So when you're picking your AK values, you want to pick them in the period that is easiest to work with for doing the math, if that makes sense.
Yeah.
The ones that are most convenient, I should say.
Okay.
But they do end up repeating to infinity. It's just we humans like the smallest numbers, I guess. The ones closest to the 0 to the y-axis.
Yeah. Okay. We humans.
That's also why we get negative numbers for those AK values. It's just because some signal might be symmetric around the y-axis. Hey James, did you happen to answer Robert's question about how long this review session is already? I don't know.
I said it until you ran out of questions, but.
Oh, gotcha.
As long as it needs to be, but we'll want to sit here and sit in silence.
Yeah, in past semesters, this thing has gone on for about 2 hours. The very first one we did when James and I recorded the session that we posted in Piazza, that one was 2 hours long. I think last semester we went to like an hour and 30 minutes or hour and 20 minutes or something like that.
Yeah.
Yeah, no problem. What we're here for.
What was I looking for? Focus problem solutions.
Robert's asking if there's any topics that weren't well covered on the first recording, and I would say no, because we go through every single midterm problem, or not midterm problem, that would be cheating. We go through every single midterm review problem.
Yeah. Yeah. That was actually our second attempt at it too. I did it the second time.
So there are a couple additional videos. So every semester, since we did that first recording, we asked the students in Piazza like a few days before we do the midterm review if they have specific questions. And if we get a topic in advance, I usually write out notes and like lecture notes almost, and I make a lecture on it. And so every time that happens, we record that lecture and it becomes available as well. So that has only happened once though. So I have I don't know, 10 or 15-minute long lecture on stability just because a student asked about it last semester. But if you guys give us topics to discuss during a review in advance, I will always make a lecture for it. So keep that in mind for the final exam. If you guys give us a topic before the final exam review, I can make a lecture. That's actually true during the course too. Like not just for review sessions. If you have a question and you say, hey, can you make a lecture that goes into more detail than the lecture that's in the course shell, and I'll be glad to make a lecture on something. No problem. Glad you could join us for this period of time at least. And good luck on the exam, Robert.
Anybody have any other questions or anything about the program? Or how you can become a TA?
Yeah, we actually do need a new TA for next semester, for the summer semester. If anybody's interested.
This will be my last semester, or last club time. Anybody wants to hang out with Woody?
Yeah.
TA'd for Dr. Wang before.
Yeah, I really don't want to do it by myself.
I'll consider that. Yeah. I'm trying to find a job and try and take these courses a little slower. They've been overwhelming a little bit, but
yeah, I'm doing the same thing. I'm working. Yeah, I work full time and I go to court. I do this school at ASU part time.
Yeah. Okay. Yeah, I found some like electrical engineering technician positions that hopefully they'll open up to one class lower of hirees.
There's always internships too.
Yeah, definitely. Got to look into those.
Or join the military.
Yeah. My two brothers have served, and they seem like they've. Seems like they're saying don't do that.
I'm in the military right now. I'm in the Air Force active duty. And,
oh wow! Thank you.
Yeah, but it's no problem. I think we should thank teachers and stuff too.
Yeah.
not just military people. Anyways, but yeah, I'm in the Air Force and active duty, and I don't know if I've had quite the standard career as most people, but I've enjoyed it so far. There's a lot of cool opportunities. You meet a lot of people, that's for sure. A lot of different kinds of people. Some of them weird and crazy, and some of them, really cool and down to earth. So it just depends where you go and what job you're in, and surround yourself. If you're an engineering student, you're going to be able to get a high ASVAB if you wanted to join the military, and you can get a good job where the people are more normal, and they have more. I don't know. They're more normal. I'll just put it that way. But if you get a low ASVAB score and you get dumped in with a bunch of let's just call them dummies, like security forces, or which is a military police. It's the Air Force term for military police.